Hello friends, I welcome you all to my channel. This video is part of the playlist Let's Solve Problems of the Mathematics class 12 from the textbook Objective NCERT at your fingertips. In this series of videos, I am trying to discuss integrals, the chapter integrals, and solve some problems from the textbook Objective NCERT at your fingertips of class 12. This book comes in one volume for both class 11 and 12. It's a good book for problem solving. I highly recommend and suggest this book for your board exams as well as competitive examinations. So in this video, I will discuss about the special form of the integral root over x square plus a square, where you can solve this integral using integration by parts in the case where you do not remember the standard results. So let's get started. Okay, so you can see I've written down the standard results of the three special form root over a square plus x square, root over a square minus x square, and root over x square minus a square. The standard results are quite complex. I mean, if you remember them, then it's good. But for me, it's very difficult to remember because there are so many standard forms. So this video is to let you know that you can, if you forget the standard results, then you can easily solve them by using integration by parts. The formula for integration by parts, you use integration by parts to solve an integral of the product of two functions fx and gx. So the integral of fx and gx dx equals to fx multiplied by the integral of gx minus the integral of the derivative of fx multiplied by the integral of gx. Now I will possibly make more videos on integration by parts. I will discuss how to choose. There is a convention to choose which one to choose as fx and which one to choose as gx in a given problem. I will discuss that in some future video. So now in this video, let's say how we can solve the integral root over a square plus x square by the integration by parts. So let's choose. So we have only one function fx, and the gx we can assume it's 1. So gx is 1 and the fx is root over a square plus x square. So if we apply the integration by parts, we get a square plus x square integration of dx, because gx is 1, minus the derivative of root over a square plus x square, which is x by a square plus x square. So basically it will be 1 by twice root over a square plus x square, and in the numerator it will be again 2x, and 2 will cancel out. So it becomes, and over here we have again dx and this whole dx. So this becomes integral of dx is x. So we have x into a square plus x square, and minus this we have again integral of dx is x. So we have x square by root over a square plus x square dx. Now we need to solve the second term. So let's call it I1. Let's solve I1. What is I1? So I1 is root over x square by root over a square plus x square. Now we can, in the numerator we can rewrite x square as x square plus a square and adjust the square, and in the denominator we have this. And if we split this, we can write this as like this. And if we split this term into two terms, we get a square, this dx minus a square by root over a square plus x square. So we have this. Now see, in the first term, this is again the same integral that we are trying to solve. The first term, this. So this is basically I. So if we say this is I, let's say this is I. So we are solving I. So we again got back I. And what is this? This is the standard result. We all know that what is the standard result for root over a square by x square? This thing, integral of 1 by root over a square plus x square, we have a standard result, which is this you must remember. So we have log of e mod x plus root over a square plus x square. This you must remember. This is a very short result. So we have this. So this implies, now this I1 was, so we got I as x root over a square plus x square minus I1. So minus I1, and I1 is this. So we have this equals a square plus x square, and what is I1 is this, I minus this. So this becomes I plus a square log x plus a square plus x square. So this implies twice I equals x into root over a square plus x square plus a square we got this. Okay, so this implies, now we got the final result, I equals to x by 2 a square plus x square plus x a square by 2 and log x plus root over a square plus x square, and finally the constant of integration. So this is how you can solve the integral root over a square plus x square using the integration by parts. In case you forget the standard results, if you remember the standard result, then it's fine, no problem. But in case you forget the standard results, you can always solve it using the integration by parts. Now remember that in these results we only see x, but actually in the problem that you will solve, the form we are solving integral of root over a square plus x square, but in actual problem when you will solve of the form problem of the form function of the form root over some quadratic expression inside, it could be not x, but here x could be x plus minus alpha, where alpha is a constant, and the result will be same, meaning root over a square plus minus alpha square dx, integral of this will be x plus minus alpha by 2 root over x a square plus x plus minus alpha square plus a square by 2 log x plus minus alpha plus root over a square and x plus minus alpha square plus constant of integration. So, in the actual problem, when you will transform the quadratic expression inside the root, it may not be in the form a square plus x square, but it could be in the form a square plus x plus minus alpha square. Now, let's try to quickly solve a problem. Let's say we are trying to solve the integral, let's say root over x square plus 2x. I'm not sure if this will be of the form a square plus x square. Let's see, plus 4 minus 4. Here, let's see. So, if we express the quadratic expression inside the root in the form a square plus x square, we get x plus 1 whole square plus 2 square. Yeah. So, instead of x, we have x plus 1. So, now considering the fact that you do not know, or you forgot the standard result of x square plus a square, what we do is we use I think this is right, x plus 1 whole square. Yes, we first you can do one thing. Instead of x plus 1, we can substitute let x plus 1 equals to t. This implies dx equals to dt. Therefore, the integral becomes t square plus 2 square dt. Now, we can use integration by parts, and we get we do integration by parts, where let's say ft, since we are having t as a variable, ft is the first function is root over square root of t square plus 2 square, and gt is 1. So, I equals to, when we apply the integration by parts, we get t square plus 4 integral of dt minus, we have to find the derivative of square root of t square plus 4, which is t by t square plus 4. Over here we again have dt. So, we have this equals to t into t square plus 4, and we have again t square by root over t square plus 4 dt. Okay, now uh, let's say this is I2, let's say this is I2, so I2 is, we are solving I2 t square. Instead of t square, we can write t square plus 4 minus 4 divided by square root of t square plus 4 dt. We split the term and we get root over t square plus 4 dt minus, we bring the 4 constant outside and we get t square 1 by square root of t square plus 4. Now this is again back to the integral we are trying to solve, I. So this is I minus what is the integral of 1 by t square plus 4? It is sine inverse, no, not sine inverse, 1 by a square plus x square. What is the standard result for 1 by square root of x square plus a square? This is log of t plus t square plus 4. Okay, so this implies I equals to t square plus 4 minus I2. This equals t into t square plus 4. What is I2? I2 is minus I plus 4 log e t plus t square plus 4. So this implies twice of I equals to t into t square plus 4 plus 4 log e t plus t square plus 4. This implies I equals to t by 2 root over t square plus 4 plus 4 by 2 log e t plus t square plus 4, the constant of integration. So this becomes, if we put back, we have substituted x plus 1 as t. So this becomes x plus 1 by 2, and this become x plus 1 x square plus 2x plus 5. This becomes, and we have plus half log x plus 1 and plus root over x square plus 2x plus 5 plus c. So this is the final result. So this was the video about how you can use the integration by parts to solve the standard form of integral form of square root of a square plus x square. In the case you forget the standard result, if you remember the standard result, is fine. You need not solve it again by integration by parts. You can directly use the standard results. So in the next video, I will similarly show how you can solve the integral of root over a square minus x square and x square minus a square using integration by parts, because these two forms, the standard results are might be for you difficult to remember. So that is all for this video. If this video was beneficial to you, then please like it, share it with your friends, and if you watch my videos regularly and if you are not yet subscribed, then I will highly request you to support my channel by subscribing to my channel, and also please do not forget to press the bell icon so that you will be notified by my future videos. Thanks for watching, and until the next video, take care and bye.